today I'm going to be talking about Algebra 1, and yeah, we're going to be talking about more about Algebra 1. So in the last two videos, we talked about lines. The lines are cool, but now we're going to talk about better things, factoring and expanding. So, oh, by the way, my name is... So, in expanding and factoring, point of that, so they're basically opposite. So, before I talk about, expanding, I'm going to talk about, before I talk about factoring, I'm going to talk about expanding. So in pre-algebra, you might have learned about the distributive property. I'm not going to write it because I'm too lazy. The distributive property states that A times B plus C equals AB plus AC. Now, an example is, what's 3 times 2 plus 4? I mean, we can do 2 plus 4, which is 6 times 3, which is 18. Or you can do 3 times 2 plus 3 times 4. And that's equal to 6 plus 12, which is equal to 18. Now, have you ever wondered why? If you have, good. If you have not, too bad. So, let's say we had a rectangle, okay? Now let's say, oh my god, why did it make a square? Cool. Back to our ugly rectangle. So now, now we know if this was A and this was B, the area is AB. Now, so we add it on to the rectangle. So notice that this is also A, and let's say this is C. Then the area of this is AC, right? So the area of the whole thing is AB plus AC. But notice, if we did not have this line at the beginning, we just have one big rectangle. And one side length is B plus C, and the other side length is A. So the area is A times B plus C. Because we have that B, so now because you can split it up, right? And it's the same either way without this line. This line doesn't do anything. It's just a divider for our own sake. Now, that means that AB plus AC, if we split it up, and if we don't split it up, we get A times B plus C. They're equal. Okay? Now, we can do that with many other things. So, let's say we did like this. So, let's say we put another divider. Then this would be C and D. This would be AC. This would be AD. And now we have B plus C plus D. So we have A times B plus C plus D is equal to AB plus AC plus AD. Right? We can also, we don't have to split it up vertically. We can split it up, or horizontally. We can split it up vertically too. So we can have that there. And then we have, oh god, this is getting annoying now. We'd have, so now let's say we had A, and here we had E. Now, this area is AB, this is AC, this is AD, this bottom area is BE, this is CE, and this is DE. So the area of the whole thing, now this is probably what you didn't learn in pre-algebra. The area of the whole thing is A plus E, right, one side, times the other side, which is B plus C plus D. And that's equal to, if we split it up, so now we have AB plus AC plus AD plus BE plus, CE plus DE. Well, this one looks a little more complicated, so we can't study it better. We can't see the pattern. But we can prove it using the distributive property. So if, now, what's happening is we're doing this A times a B, A times a C, A times a D. So we have AB plus AC plus AD. Then what we're doing is we're doing the BE, or E times B, E times C, and E times D. So we're going to get BE, right? BE, EC, EC, ED, ED, right? Now, I'm going to do it in a color code. So I'm going to do this so that you can kind of see what's going on. So first we're going to write in white. So now the first color is going to be red. Okay, A plus E, right? Then we're going to have B. Then we're going to have C. Then we're finally going to have D. Now we expand it. We get AB plus AC. So tedious. Okay. Where's the yellow bellow? AC plus AD plus, now I'm going to do it in the next line. Okay, first of all, because I'm running out of space and you can see it better. Now the first one's going to be E, right? Okay. E times B. Wait, what am I doing? Okay, yeah. And another. Cool. Now, cool. Now, so we have A B A C A D, E B E C E D. Cool, right? So now I'm gonna prove that to you by just using the distributive property. So I'm gonna use a thing called YUH substitution. We use this a lot in Algebra 2 and Calc and Pre-Calc and stuff like that. But it's nothing really complicated. It's just a simple method for complicated things. So YUH substitution, it doesn't really have to be U, but it can be any letter. You can substitute that for a bigger expression so you can simplify the whole thing. So now we're gonna do that in this case. We're gonna say that A plus E equals U. Okay? U is just a substitution for A plus E. Just because we don't want to write out A plus E, so we're just gonna use U. So now what we're gonna have is U times B plus C plus D. But this is just a distributive property, right? That's equal to UB plus UC plus UD. Now we can plug back U equals A plus E. And we're going to get A plus E times B plus A plus E times C plus A plus E times D. D, right? So now this is just three more distributive properties. So we have AB plus EB plus AC plus EC plus AD plus ED, right? I'm gonna keep that in parentheses. Now we can remove the parentheses, right? Because yeah. And now we notice this is just the same thing as this one, just because of commutative property of addition. So now let's say you had something like, who's been writing here? Let's say you had something like A plus B plus C times D plus E plus F plus G. Okay, now this one might seem a little easy so far, so I'm gonna make it a little harder. Times H plus I plus J. Okay, now it's a little harder. So, how can we do this? Well, I'm not really sure about you, but that seems kind of ugly, so I'm not gonna do that right now. What I am gonna do is I'm gonna look for a pattern. So with this one, A plus E times B plus C plus D, notice that in this one there's 2, and this one there's 3, and this one there's 6 terms, right? So 2 times 3 equals 6. And now, what else are we gonna notice is that A goes with, so this first term goes with everything here, and the second term goes with everything here. But notice we don't have any BCs, BDs, CDs, and AEs. We don't have any of those. That's because they're in the same set of parentheses, right? AE is together, BC, BD, and CD are all together, so we don't use those. We use everything else, every combination of 2. So we have, so what we're really doing is when we have these type of things, so then we just do the first one times everything, and the second times everything in the third. But now in this one is 3. So what we're really doing in these ones is we're just doing every combination in everything. So we're gonna choose one from this one, and we're gonna choose one from this one, and we're gonna multiply them, and every combination of that. If we're gonna have 3 of them, if we had like A plus B times C plus D times E plus F, we do every combination. So we take the first, so we'd have A, C, and E plus A, D, and F, or plus A, D, and E. Then we're gonna have A, D, and wait, what am I doing? No, sorry, no. We're gonna first do, so we're gonna have A, so we're gonna do A, C, and E. Then we're gonna do A, C, and F. Then we're gonna do A, D, and E. Then we're gonna do A, D, F. We use that with everything else. So we're just really organizing this and doing them first by second by third, and we're just doing every combination. So we're gonna have now we're gonna have B, C, E plus B, C, F plus B, D, E plus B, D, F. What am I doing? Okay, yeah. So when we do this, we want to check. So by the way, there's no AB, no CD, and no EF. To check, what we do is we look how many are in each parentheses. So in the first one we have 2, A and B, C and D, which is 2, E and F, which is 2. And that means that our total terms in the end should be 2 times 2 times 2, which is 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're all good. Now for this one, this ugly challenge that I've given you, we're not gonna have 8 terms. We're actually gonna have 3 times 4 times 3, or 36 terms. We might as well just write it out loud. I'd say that you try this on your own. And remember, every combination except for the terms that are in its own parentheses. So you do A times, so yeah, and because there are 3 sets of parentheses, you do, then every term will have 3, every ending term, it's gonna have 3 terms from this. So we're gonna have, like in the, so like, because of 3 terms of parentheses, we're gonna multiply 1 from the first, 1 from the second, 1 from the third, and every combination of that. Yeah, and if you're not understanding what I'm saying, which is probably really likely, just do distributive property and use substitution. Okay, give it a try. Okay, I assume you've tried or at least had an idea about this, or maybe just got a head start. But yeah, let's try this. So I'm not gonna use substitution. I'm just gonna do every combination. So we're gonna have ADH. Oh, wait, let me do it here. ADH, right? We do the first times the first times the first. Then we do the first times the second times the first. Wait, yeah, no, we're gonna do the first times the first times the second. Sorry. So A D I plus first times third. A D J. Now we've now we're gonna do first times second times first. A E H first times second times second, AE8I, first times second times third, AEJ. Plus, we're gonna do first times, AEJ. Okay, now we're gonna do, what are we gonna do? We're gonna do first times, so we did AEJ. Okay, now we're gonna do first times third times first, plus first times third times second. Sorry, no, you can't have HFJ in this. First times third, so we did first times, okay, first times third, AF times first, which gets us to H, plus, okay, now we're also gonna have now we're gonna have G instead of F, G, H, A, G, I, A, G, J. Now back to, back to here. We're gonna have second, and this last one's gonna be C. Notice now we just repeat everything. So we have DH, DI, DJ, EH, EI, EJ, FH, FI, FJ, GH, GI, GJ. Now the tip is not to memorize this, and don't memorize every single case. There's a lot. Just understand it and it'll be good. CDI, CDJ, CEH, CEI, CEJ, and CEJ, CFH, CFI, CFJ, CGH, CGI, CGJ. Okay, that's the whole thing. And to check, we need to have 36 terms. So in every row, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there are 3 rows, so we have 36 terms. And that's good. Okay. Now, we learned about expanding. What about factoring? If we had something like this, how would we know what it began like? So now our goal is to factor this. Factor means to, so let's say so if you were to factor 24, you can have it 6 times 4, 3 times 8. You can even have it as 2 times 2 times 2 times 3, right? Couldn't think. So factor just means something, and that something is something. So hopefully you learn the basics of factoring in pre-algebra, and we can build upon that. So let's say we had something like this, right? And how would we factor that? That's our goal. Now, before we do that, we're gonna want to first learn the basics. So let's say we had AB plus AC. How do we factor that? So first I want to show you kind of diagram of the distributive of something. So let's say we had A plus B. Let's say you had something like A times B plus C. And we know and then that's going to be equal to AB plus AC. So to get from there to there, you use expansion, and to get from there back, you use factoring. So how do we do that? So we first notice that there's an A in both of them, right? So what we can do is we can factor out an A. So if we add AB plus AC, they both have an A, so we can bring out this A, and we get A times, we'd be left with B plus C if we remove the A's. If we add A plus AD, we'd remove that A plus D. Done. Simple. Now, if you had it with uglier things like this one over here, what would you do? So let's go back to this example where we had AB plus EB plus AC plus EC plus AD plus ED. So you can't really, there's nothing in all of them. But what we can do is we can notice that this first one is B times A plus E. The second one is C times A plus E. And the third one is D times A plus E. Now they all have an A plus E. So we have A plus E times B plus C plus D. Simple. Hopefully. Now, all we have to do is just take chunks at a time. So you take this chunk, take this chunk, take this chunk. Then you factor them all separately, and then you take the whole thing. Now let's go back to this big problem. So we notice that in the first one we have A times a lot of things, and then I'll just leave that to you as an exercise. I know you guys know the answer, but just do it as an exercise, try it out. Yeah. Try to so like bring an ugly expression and then expand it and then factor it. Okay, cool. Thanks for watching. Goodbye.